Okay, this skill builder is called Name That Motion, and part of the reason for having this activity is for you to get more comfortable with some of these terms such as velocity and acceleration, and for you to recognize that velocity and acceleration are both vector quantities. What that means is that they have direction as well as magnitude. They can be described by a number, but also by a direction. So what you do is you just enter into this and you choose, there's a bunch of different animations. I'm just going to start with the animation 1. You can do as many or as few of these as you want. And what happens is you see a car moving along, and it's essentially creating a motion diagram. What this means is that it's going to put a dot at regular intervals. So each time it puts a dot, not only do we know the position of that car, but we also know that the time between a particular dot and the previous dot, as well as the successive dot or succeeding dot, the time intervals are all the same. So it might be doing a dot every tenth of a second or something like that. But the important thing is that every time you see a dot, you know that an equal amount of time has elapsed between dots. So we look at this motion diagram and we can pick out a few things. And again, you'll get some experience or some practice with this in the Module 1 lecture mix is what I call these things, as well as the Module 2 lecture mix. So you may actually have to do a little bit of previewing and watch the section about speeding up and slowing down, and you'll get more examples of this. But notice what's happening in this particular motion diagram. The dots are all evenly spaced. If I measured the distance between any two dots, I would get the same answer over and over again. Of course, we know that speed is distance divided by time. So it doesn't matter which two dots I measure, I'll get the same distance. And notice that because this is a motion diagram, the time between any two dots is always the same. So if my distance is the same and my time is the same, then my average speed between any two dots is always the same. So essentially my car was moving along here at a constant speed. But one thing that's also important to notice is that the car was moving to the left. When I start including not only speed, but also the direction, I'm really talking about velocity. So let's take a look at some of these descriptions first of all and see if any of them make sense. Well, this one says the car moves with a rightward velocity and a rightward acceleration. We can essentially just throw this one out right off the bat, because notice the car was not moving rightward, it was moving to the left. So throw that one out. We'll worry about acceleration a little later. Okay, the car moves with a constant leftward velocity, then the car remains at rest for several seconds. Finally, it moves with a rightward. Again, our car never stopped. It constantly was going to the left. Okay, the car moves with a constant leftward velocity. That sounds pretty good to me. Let's check it. And sure enough, we get the correct answer. Then you return to the main screen and you go through the rest of them. It'll put stars beside the ones you've already done. But again, this will give you a chance to get practice with the terms velocity and acceleration. So if you have problems with the acceleration part, I encourage you to preview the Module 2 lecture mix, at least the early section where it talks about speeding up and slowing down, and you'll see me waving my hand in front of myself, pretending that I've got a little speedometer. That may help you sort out the direction of acceleration, left or right, as those can be a little bit on the tricky side.